Put your RAG bot on the witness stand. Ask it one connected question. Did the company that acquired our vendor change its compliance policy? On the evidence board, that is 3 distinct exhibits: the vendor, the acquirer, the policy. To win the case, you have to connect all 3 with the red string. But watch what your pipeline did before the trial even started. To store your documents, it took a pair of scissors and shredded the original lawbook into loose paragraphs. The red string is cut. The exhibits are scattered. That arbitrary shredding destroys the chain of custody, leaving the system to guess where one fact ends and the next begins. So the old clerk does the only thing it can. It guesses. It scans a giant 3D coordinate map, relying entirely on fuzzy mathematical similarity. It grabs whichever unrelated scraps of confetti happen to look similar. No logical connections, just a brute force hunch. Case dismissed. For complex, multi-hop questions, standard similarity matching loses the trail before the judge reads a single word. For 15 years, we swore the answer was this map. Every idea, a coordinate. Every search, a distance. So here is the heresy. We sack the old map, watch it shatter completely. Every vector, gone. We trade mathematical matching for pure logical reasoning. Stop asking what looks closest. The smartest way to search a complex structured document was never billion-dimension math. It is handing the machine the one thing it never had, the table of contents. We are done with the shredded lawbook. Now we build the tree. This diagram outlines our new 4-layer architecture. At the foundation is the document store. The original lawbooks remain completely whole, untouched by shredders. Above it, the global directory branches out. This functions as one master table of contents. Remember this name. This is the logical directory. Beneath that directory sit the chapter summaries, one gist per branch. Entire sections can be evaluated without reading full pages. And at the end of the line are the leaves, the exact pages, section 1.2, pulled perfectly on demand through an unbroken relational path. Books, directory, summaries, pages. This 4-layer architecture protects the structural integrity that chunking destroys. We hand the judge a perfectly ordered library instead of random confetti. When a case begins, the AI enters the system at the very top of the tree. It reads only the directory map instead of the full territory of books. From there, it filters at high speed. Chapter 2, irrelevant. Chapter 3, irrelevant, struck from the record. Most of the archive is dismissed, with 0 pages actually read. Bypassing the noise, the system drops straight down the correct branch to the exact ruling page. To secure a precise verdict, the rule is simple. Navigate intact structure. Never scan for scattered similarities. So which clerk do you put on the case Monday morning? Choose wrong, you drown in vector soup, or you overbuild a tree you never needed. This side-by-side graphic contrasts the 2 native environments. On the left, the old clerk lives in mathematical vector spaces. On the right, the new clerk lives in the document's own structural logical skeleton. The old clerk relies on arbitrary chunking, severing context. The new clerk preserves 100% of the document structure. And under pressure, one clerk guesses by matching words, while the other hops precisely from fact to fact, following the chain of custody. For fuzzy, messy, open-ended search, vectors still shine. But for structured documents and complex multi-hop questions, you call the tree. No matter how smart your LLM is, it can only be as precise as the evidence it can actually find. 2 clerks, 1 verdict is yours to make. If this changed how you see AI architecture, subscribe for our next deep dive.